Yeah, thanks to everyone. I'm also sorry for the inconvenience. I also by myself wouldn't have thought that so many people were really coming. So we also have a second screen over there in case it's a bit hard to sit there. And welcome to the session about Beyond Jupyter Notebooks. So I'd like to share my experience. Actually, I gathered going from Jupyter towards Docker. So just a little bit about myself. I'm currently working as a full-time data scientist for BMW, so the nice cars. And I'm mainly working with sensor data extracted from the cars. We will not do anything with car data, but that's just as a background. I'm also enrolled in a remote master's program in data science, with actually is hosted by a little village in Germany. So Albstadt, who of you knows Albstadt? Okay, maybe not that quite small, in cooperation with the University of Mannheim. My motivation of this talk is that you do not get each and every piece of it, but that you're motivated to go on your own and say, okay, I like to try this out. I like to go into this direction. So don't worry if you don't get everything. Also, as a small disclaimer, if you like to take notes, you can go on, or you do it the easy way. You can simply store this repository. This contains the slides, the references, and all other stuff that you need. So I think I'll wait until everybody takes a picture. And maybe I can talk a bit about the motivation, why you should go beyond Jupyter. So if you followed the news, you might have heard that data science is supposed to be the sexiest job of the 21st century. And doing it, I can partly agree to that. On the other hand, I have to admit that, yes, it's sexy, but you often have a lot of irreproducible and spaghetti code. And what I figured out is that it's mainly because of Jupyter. So Jupyter is great. We're also going to use it. We're going to build our own platform with Jupyter at the core. But there are certain things you might want to reconsider moving out of Jupyter. It's actually also quite funny because there was the JupyterCon this year, so a conference just for Jupyter, where a very knowledgeable Pythonista had a talk. And his talk was, I don't like notebooks. So who of you has seen this talk? One person, two person, cool. So the others, you should check it out. It's really funny, the story he made up, and he really claims why Jupyter is bad for certain stuff. But I'd like to go one level above that, not only picking on Jupyter, but in general say, okay, if you do data science, you'll reach a certain point where you have some problems and trying to help you in advance with those problems. So what's the ugly truth if you'd like to do data science? There are a lot of challenges. Some challenges come because of your organizations, some of other reasons, and I try to come up with 4 tangible challenges. Those will guide as a kind of red thread throughout the talk. The first are the static visualizations. So as you'll see, we have a lot of Python libraries producing nice charts, but up to a certain point, they're quite static, which is nice if we would have the year 2000, but we have 2018. So people want to have something to play with. The next point is the isolated flat data files or data files in general. I think who of you ever used Jupyter came to a situation where you had, okay, this is my data export.csv. This is my data export underscore new CSV. This is my data export underscore new, really new CSV. And for those of you laughing, I think you can relate. We can see how we can tackle this problem. The next point is a bit special to data science, so model retraining. Why should I retrain my model? Assuming you're building a weather forecast model and you have the data from the past week, you're building a model, you're predicting the weather for the next week passes, and what now? Your model is actually outdated because you actually have a week of more data you can put into your model. So we see how we can do this outside of Jupyter. And the last thing, which is also quite important, is, okay, we did some really great data gathering, built some awesome models, but how do we share it? How do we get our model to work with other people? Optimally business people. They don't know how to code, they don't want to code. But how can we make it still accessible for them? So these are the 4 main problems I'd like to cover. As mentioned, there might be more. You might not agree with all of those, but let's see how we go. Also, as a disclaimer, if you have questions, we're going to have a Q&A section at the end where you can shoot all your questions out. Coming to Jupyter. So, who of you knows Jupyter? Please raise your hands. All right, almost everyone. So, as you also might know, Jupyter as an interactive programming environment currently supports over 100 different kernels, and we can access it via the browser. So, actually, let's do so. All right. Yeah. Ah. I hope I got it right this time. Okay, last try. Caps lock, sorry. There we go. So I prepared a few notebooks, which we'll also use throughout this talk. And we're not predicting flowers, we're not predicting the survival of the Titanic, but we're predicting wine, which is also quite a common use case because scikit-learn gives us the data. I'll probably go rather quickly through this little demonstration because the majority of you already knows Jupyter. We can have our Python code run in Jupyter. We can also inspect data frames. As I mentioned, this is the wine data set from scikit-learn. It's actually built to give you data for a classification task. So we have 3 different wine classes, and the goal is to have all the technical information like alcohol level, the malic acid, the ash, and so on, to predict whether it's wine 1, 2, 3. We can also, as mentioned, produce some nice plots, and we'll focus on those plots in the next chapter. So for instance, some seaborn plots, some matplotlib plots. I guess nothing for you. Let's also dump this data because we need it later on in the CSV. Coming back to our little presentation, maybe the next question for you. Who of you runs Jupyter by simply running the Jupyter command and launch it on the host machine directly? Okay. Who of you runs Jupyter inside of a Docker container? Okay. So I would say still 2 to 1. But let's see. So this one you've seen right now was actually a Dockerized version, and you couldn't have told the difference. Everything you have to do in order to run this container is quite simple. So what you say, docker run, is the command, hey Docker, spin up a container for me. And the last command is the image name. So Docker has a huge variety of images, a lot of images from the community, and we're actually using the Jupyter/SciPy notebook because it contains all the nice data science stuff for Python we need. The parts in the middle are very crucial. So the first parameter is /d. What does -d do? Well, if you go to your terminal and you run this command without -d, what it will do, it will log all the output to your terminal, which is not that nice. So what you do, you close the terminal and therefore you kill the container. -d helps you by letting the container run in the background. So very important. Also the second option. The thing is, if we have our Jupyter container and it has a port 4x8 and it does some really interesting stuff on that port, we cannot access it directly unless we explicitly say host system, take the port 4x8 and match it to the port 4x8 from the container. So yet again, this is really the minimal command you have to run in order to get a nice, flexible Jupyter and a Docker container. I promised you to build some interesting architecture. Does this look interesting to you? No, of course not. This is totally boring. I mean, this is where we are right now. We have a Jupyter container, that's it. So let's proceed and go to the first problem, static visualizations. And what do I mean by that? This is one example, and it might not be the best code, but it's my version of 17 lines of code producing this chart. Is this chart sexy? If you were the manager and one of your employees would come to you and say, look at my chart, would you say, well, you get a pay raise? Obviously not. I mean, some of you might say, well, but what about Bouquet or Plotly or Dash and all the other fancy stuff? Yeah, you can do also some interacting visualizations within those libraries, also within the Jupyter container. But I'd like to show you a slightly different solution. And you can still say, well, I like the other more. Who of you has worked with superset before? Nice. Only 2 people in the room. So, superset is actually some kind of visual analytics tool. And the good thing is it's completely open source. So that was also one of my motivation to provide you with a stack that's completely open source. It originated at Airbnb, is now an Apache top-level project. It runs in the browser, has a quite nice UI, and I would suggest simply check it out. Yet again, second time login. There you go. As you can see, Superset already has quite some nice UI. Seems to have some quite non-technical features like the user management, but I'll promise they come in handy if you need them. And what I would like to do, I would just create a very simple chart, a very simple dashboard, so you can see what are the steps. Because when I first used Superset, it took me a whole weekend to understand, okay, I have a CSV, and I only want to have a simple chart. Why the heck does it take so long? So there's some little things you have to consider, but we'll walk through them together, so don't worry. The first step you have to do is to provide a source. This can either be a database, so you can provide connection strings, or a CSV. For now, let's just upload the CSV. Therefore, we download our data. Oh, not the semantic web stuff, but the desktop. Let's call it line. Leave the rest as it is. And now we have the data. And we're almost ready to visualize this. But this is now the tricky part. Whenever you'd like to visualize data in superset, a superset distinguishes between metrics and dimensions. At least that's how I would call it. So for those of you working in data warehousing, this might sound quite familiar. What do I mean by that? Well, you have metrics. These are the real values, like amount of euro or weight or height, the stuff you'd like to display. And you have dimensions. So you always have a certain view onto the data. Meaning, okay, I would like to see, for instance, height by gender or income per age. And these are dimensions, and we have to configure them first. Otherwise, the charting won't work. You will be upset. You will blame it on me. Nobody's happy. Luckily, it's quite easy. So by default, superset takes the tick mark in the end and the sum, and thereby makes everything a metric. And if we consider, okay, we have wine data, let's plot the average alcohol per wine class. Alcohol is already a metric. Per wine class means this class has to become a dimension. And it doesn't hurt. It's quite easy. That's it. We just simply have to do a tick mark. We can make it groupable and filterable. Actually, we don't sum over it. And now our data is ready to be visualized. So let's go ahead and create a chart. Out of the box, Superset comes with quite a lot of visualizations. And of course, some of you will say, but where are my scatter plots? Where are my box plots? The bitter truth is that Superset doesn't provide it for you for a certain reason, because Superset was born as some sort of business visualization tool. So they have a very good support for time series data and for geospatial data. Because of course, the Airbnb manager want to see where is the highest profit, what is the profit over time. They're not that interested in some standard correlation plots. But as I mentioned, just as a side note in your head, if you're very good at programming React, you can come up with your own visualizations. I guess the whole Superset community would thank you for that. But let's just start with a simple bar chart. As we say, let's take the average alcohol per class, run it, and there you go. So this is the first visualization. I didn't program any Python. I just clicked around. And what I can do now, I can say save as wine. Oops. I can add it to a new dashboard. Save it. And I'd like to show you something very handy. I mean, I don't want to explore each and every chart type, but one chart type is very interesting. This is the filter option. Because you could argue, well, I can also do the same in Jupyter. Where's the benefit? Well, the benefit comes in if you really start creating filters, which you can also put in your dashboard. So you can on the fly say, only show this table or only show this chart with records that have certain conditions. Yet again, a bit tricky. A filter is a chart type, of course. I thought that. And it's the filter box. We only have to say, okay, let's go to the average alcohol. This is how the filter, okay, I ran into an error. This could also happen to you. Why can't I do this? Because, going one step back, I have to configure it in the database, or actually in the table. But that's also quite easy. That's just this little tick mark. So let's say we want to have filter by magnesium level, make a tick mark, that's it. So let's proceed. Filter box. And now it should be available here. If we run the query, yep. Yet again, it shows us the state options. We don't want that. And we simply add it to our dashboard. Let's call it filter. Let's add it to an existing dashboard. And let's go to the dashboard. This is what a dashboard looks like. Okay, quite boring, but I have limited amount of time and there are other topics I like to cover. But what you can do right now is to simply say, okay, only give me the wines that have a magnesium level of 88 or 89. I think it's milligram per liter or something like that. And this is something which comes quite handy. So you can give this tool really to business users and business analysts who do not know how to program code to still come up with nice and interactive visualizations. And yet again, this is totally open source, so you don't have to pay some sort of expensive license fees. Good. Yet again, this is the Docker command. It looks exactly the same. The only difference we had is that we exchanged the ports, because by default, superset runs on port 8088. And we, of course, have to exchange the image. So our architecture is growing. Well, still not that cool, fancy data science environment, but we're going. One problem we still have, and you might also raise this now, is to say, so this means whenever I have a new kind of CSV, I have to upload it. I don't want to do this, because maybe I have tons of data floating around. This doesn't help me. Luckily, who knows this little boy? Cool. The majority. Luckily, we have databases. And I just pick Postgres. You can pick the database of your choice. You can go NoSQL, crazy, whatever you like. But what we're basically going to do, we just add another component because it's quite easy having Postgres in the middle between those two. I'm also not going to show you the basics of database, like insert into and select, because I think that's quite common. Just one point where we'd like to go to. In superset, or general in the Python world, you can use the SQL Alchemy package to create connections to databases. And this is how a database connection string looks like. And maybe you from the back, for you it looks a bit weird because it's basically Postgres, 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 Postgres. But all of these little Postgres have a special meaning. Yet again, a little pitfall I'd like to cover. So the first Postgres is actually PostgreSQL is the dialect. So we're talking to a Postgres database. Then we have the username, followed by the password. So all the security experts see totally unsecure because username equals password. And the last one is the host, sorry. So the last one is the host. And currently, if we would simply say, okay, I have another Docker command, I spin up my Postgres, this wouldn't work. Why wouldn't this work? Because all the containers we had at Jupyter, superset, and Postgres, they're spun up independently. So they don't know each other. They can't refer to each other by name. But luckily there's a solution to this, and this is Docker Compose. So Docker Compose is also a tool which comes with Docker, which can do exactly that. Because if we spin up the stack with Docker Compose, and you'll see the code in a second, this is what happens. All of the containers, they're getting attached to a virtual network, and now they can address themselves by name. It doesn't sound so cool or interesting, but it is really a major thing. Because and no matter if I'm in Superset or Jupyter, I can simply use this and directly refer to Postgres by say at Postgres. This is actually how such a Docker Compose file looks like. So it works a bit different. You first specify your complete infrastructure inside of this Docker Compose file, and then you say Docker Compose up. As you see, actually all the stuff we did was having the Docker command, wrapped it around. So we say we're using Docker Compose version 3. And now we're just listing all services. We want to have a Jupyter service. We can give it a name. Same image, the same ports. We want to have a superset image. Same image, same ports. Now for the Postgres, there's something special because by definition, databases were invented to store data. And containers are ephemeral. So a container might die. And it's useless if I have a container as a database container. It doesn't persist the data. So what we can do, we can actually introduce a so-called Docker volume. So that's kind of virtually managed volume by Docker. And we can simply mount it into the path where Postgres internally stores the data. Therefore, we can spin this up, kill the Postgres container, ramp it up again, and the data is still there. And this is the only command we have to use, so quite easy. But what about the model? This works quite well if I have tabular data. I can put in data frame, can push it to the relational database. But what about my models? So for those of you who build models with scikit-learn, the most common way to put them onto disk is to serialize them as a binary pickle file. But luckily, there's yet another open source solution for that. Who knows this little bird? You're quite knowledgeable. Exactly, it's Minio. So Minio is an S3 compatible object store. Now, what is an object store? There are discussions on the web what an object store is, and I would simply refer to it as a key value store. Inside of an object store, you have buckets. Inside of these buckets, you have file names, and behind those file names, you have the file itself. So you can think of it as, okay, I create a folder, I dump something in it, that's it. Of course, you can say, well, but why don't I use the binary large object storage from Postgres? You can. But as I'll show you, Minio comes with some very interesting stuff I'd really recommend to use. And of course, it has a nice web UI, so let's check it out. Okay, so this is how it looks like. And if we say we'd like to upload some stuff with the web UI, it's quite easy. We have a little red button down here, and we have two options, create a bucket or upload a file. So create a bucket, test, can navigate to that bucket, and now we can upload any sort of file. So for instance, that doesn't make too much sense, but we can simply upload stuff. That's it. And now I have some sort of database that stores my data, which doesn't fit into relational databases. The also nice thing, as I mentioned, it's an S3 compatible object store. So those of you who work with Amazon Web Services, there's the simple storage service, the S3 option, and with just a single line of configuration I have to change, my data doesn't get persisted on disk, but into an S3 bucket on AWS, which comes handy. You don't have to use it, but for a lot of people it's handy. So the question is now, okay, that looks interesting, but what do we do with it? Before we answer that, just to show you that it is, in fact, quite easy, how to add this component, well, simply write it in a Docker Compose file. We have a new menu service, give it a name, we have a pre-built image, we don't have to care about anything. Yet again, the volumes to persisted, the ports, and now there's something new, where some people are a bit confused about, and this is the command section. So based on your Docker image, there are two options. Either your Docker image was built by within so-called entry point. So this is the script that runs whenever you spin up the container. Or like Minio, you still have to provide the command. So you spin up the server or spin up the component. And now you have to say, okay, now I want you to do this exactly. And this is the case with Minio. So when Minio starts, I want Minio to execute the command server/data, which simply spins up the web UI and locks everything under /data. Now let's go actually back. Because as I told you, I've prepared some other notebooks. Oh, I actually forgot this one. So this is to show you that it really works if I'd like to directly talk to my Postgres. I actually created a shared user. Now I did a bit properly with a password, and I say add Postgres. So I know it doesn't look like magic, but this is real magic. This little add Postgres, because inside of my Jupyter, I simply say, go to the Jupyter container or the Jupyter host, the Postgres host, and serialize it. So what we have now, we have a Postgres data inside. And now we're coming to the point of building a model and storing the model to Minio. Now, as a disclaimer, this is not a lecture about machine learning. So those of you who know machine learning will know that make a lot of errors doing this. I don't do cross-validation, any other model checking, but I show you, you can run a model, store the model, put it away. Actually, this is loading now from the database, not from the CSV file. We make a test train split. We have a random forest classifier with an accuracy of 97.2, which yet again isn't really validated. And now is the question, how do I store this? And actually, storing is quite easy. We create a Minio client, very Python friendly. And yet again, this is the magic. And in my Minio client, I can simply say the endpoint, it's called Minio. And Docker automatically can resolve that. I have the secret and access key. Let's create a bucket. We call it model. And let's actually dump that random forest classifier to that bucket. Cool. No error. Let's check it. If it worked, we have our model and we have the random forest. So in terms of thinking of architecture, where are we now? This is actually what we have at the moment. We have our computation done inside of Jupyter. Yet again, Jupyter is a cool tool, but the data, we store it differently. We have all the tabular data floating into the Postgres, might be visualized with superset, all the models into Minio. And models is just one thing. Whenever you'd like to train something on images, videos, sound files, or any other stuff that doesn't fit in a relational database, Minio is really great. Now the question is, okay, we built a nice model, but how can we share it? So there are different options. You could either have the binary pickle file and send it around via email. Doesn't sound too good. You can have a Jupyter notebook and store it somewhere, send it around. Also not the best option. Maybe the best option in this case would be to give some people access to Minio, but the problem is they still have to deploy it somewhere. But luckily there is another project. Who knows what this project is about? Okay. Nobody? So this is actually a Python framework. So, who of you knows Flask? Okay. So this is basically like Flask. This is called AP Star. It's also a Python project. And up to version 0.5, it was also built with a site and server. So what you basically do, you wrap your functions around some endpoint specifications, you launch that, and you can do HTTP calls to trigger Python action. That's it. So if you say, but I want to use Flask, go ahead with Flask. I want to go Django, Pyramid, you can do it. It's totally up to you. The reason why I thought API stuff would be nice is because with an automatic API generation. But I'm actually not too much into Flask, so this option might be also available there. Yet again, let's see what this endpoint is all about. Okay, so this is what I mean. This is nothing I have programmed. This comes explicitly or implicitly if I simply have an API stuff server. So currently we have two endpoints. The one is an empty endpoint. It prints 42, which is, of course, really important for us. And the second endpoint is a predict endpoint, meaning that, okay, we can take some parameter inside of our HTTP request, and we can give you back a result, because this is where we actually want to go. We want some sort of protect our model from being exploited up to a certain point. So if we have some other people who want to work with our model, we give him an HTTP endpoint. He can send all the variables, all the combinations of feature in the question string, and you get back the result. Nothing more. Now let's see if it works. That's always the interesting part, because sometimes, especially Chrome, seems to cache some weird stuff. Okay, this works. Cool. Totally useless. But as you can see, and yet again, I'm not an API engineer, so there might be a lot of stuff you shouldn't do when you're designing your API, but I just did it for the sake of presentation. As you can see, I can specify the parameter name inside of a question string here, and Python can work with it. Now, the more interesting option can also predict with something. So this might take a bit. Cool. This is what I get back. So I didn't specify anything, and inside of my endpoint, I said, okay, if you don't specify anything, take just a dummy value for all the parameters set to 0. But I can do exactly the same stuff right now. I can say, okay, what if the alcohol level is 100? And I actually didn't check. Did it at least change? No. Okay, so might we have to, maybe this has no influence on our model. Okay. So I'm actually not too deep into the model and know what parameter we have to change in order to change the probabilities. If the random forest just says this is the way it is, then it is the way it is. But you can now have this endpoint, and you can have any combination of feature inputs, put it into here, and you get back the probabilities, which comes quite handy because you don't have to send around any files or models. Good. Now it becomes a bit more tricky because API star doesn't give you a community image. As you see in line 36, we don't have image, but this time we have build. And this is also a step where a lot of people, they say, whoa, I'm not a software engineer. I don't want to build some images. I want to use them, yes, but not building. But I can promise you building images is quite easy. That's everything we need for our application we saw right now. So what it basically say, and I think after that we have a presentation and some more topics, so I don't want to go into detail on each and everything, but we basically say, okay, I would like to build something with Python version 3. This is the base image. Now I change my current directory inside of a different directory because later we would like to put our Python files inside there. We run a pip install. Also note the no cache because we don't want to have it as lean as possible. We need AP star, in this case to unicorn, because we represent a unicorn. And this is also very crucial, we expose a port. If you leave out the last line, what you do, you have actually a running API star locked into your container, which cannot communicate to your host system. For whom of you does it look terrifying? Who of you says, well, I think I could do it on my own? Come on, guys, it's not that hard. So cool. Message to you, building images is not that hard, as it might sound like. Now I think our architecture is really growing and growing. So what do we have? We can have our computations, we can store our tabular data, non-tabular data, we can expose or visualize our tabular data with superset, and we can expose our models with an HTTP endpoint. Now there's one last thing, and that's also a bit special maybe to data science, and this is the difficult model retraining. So this is what we actually did. We had data, we had a very fancy model, and we generated some results. Threw it over the fence, that's it. But that's actually not what we would like to do. We like to improve the quality of a model whenever we get new data. Or we might want to fetch new data every week. So what we actually would like to do have data, model, results, feedback, and this as a loop. And now the question is, okay, we need some sort of scheduling. And now, what is this tool? Yes, sir. Exactly. So who of you knows cron tabs or cron jobs? Okay, so you can think of Airflow actually just like cron jobs on steroids. This is really a scheduling engine, which has, yet again, a nice UI for the browser. It was also founded in Airbnb and now also became an Apache project. Before I show you the UI, just one little thing. I think also not too complicated. Airflow works with the terminology of task and DAG. So a task is an atomic operation, can be a Python operation, HTTP operation, bash operation, and so on, and so on, and so on. And all those tasks have to be orchestrated inside of a DAG, a directed acyclic graph. And this is what you can then schedule as often as you'd like to. Enough of talking. Let's simply dive into it. I'm also happy that I have the speed dials, otherwise it would take years. So I have 2 DAGs here. As you can see, I have a nice clean overview. Let's simply take a look what the first DAG does. Well, the first DAG is some sort of simulation that have new data arriving. Imagine you have an API you'd like to scrape every 30 minutes or whatsoever. You can do it actually the same. What we have a Python callable. This is actually just mocking it by collecting 10 random data sets from our database and writing them back. It's logging some stuff, and that's it. And also the meta information you have to provide to your DAG is not that complicated. You simply say, okay, I started yesterday, officially the first time. I run every 30 seconds. I have the Python callable as the task. That's it. Now, if you like to run it, the only thing you have to do is to activate it. Now you refresh. Nice. And you see that this DAG one was successful. You can also take the log file and validate by the log that it was successful. And you can do whatever you like. So as I mentioned, this is very simple. One task, one DAG. You can do whatever crazy stuff you'd like to do. And also the model retraining. I think I promised it to you. So this is how it looked like. What the retrain model would do, also kept it very simple. Create a Minio client. Fetch our model. Now, also not the best kind of version, but at least some difference. Fetch all the data we have gathered by now. Train the model on the data and store it. And the nice thing is, if you actually automate it this way, you can attach stuff like timestamps onto your model and persistent bucket. So you're always able to go back in time. For instance, if your manager says, well, last week our model was way better, what happened in the meantime? If you just overwrite your model or do it the Jupyter way by just renaming it and storing it somewhere, it's hard to tell. If you do it that way, you have a clear timestamp and know exactly when was this model deployed. So yet again, and I hope that this also works. Last time it was not working. Fingers crossed. Yes, nice. And we can now also take a look at Minio. There you go. And we can see we have new models stored in there. Yet again, these are dummy models. They don't have a lot of analytical value, but to give you an idea what you can do, that's actually it. The nice thing is they're a really good community image for Airflow from the user Puckle. What little stuff, just to explain it to you, is we have the depends on flag. So all that stuff you saw right now, Airflow has to write it somewhere. So we actually just put all that stuff also in the postgres, which we can do easily because we already have it in a stack. And this is really the final architecture we came to. So doing the computation, if you want to do it or scheduled, storing tabular data, storing your models, exposing your models, or visualizing your data. So coming back to all the pains, to my pains, my experience pains, these are actually all addressed by the architecture. And actually we turned these ugly truths into a beautiful truth. Because what did we gain? We gained portability. I can take any one of you, send you my Docker Compose file, and assuming you have Docker installed, you have the same architecture. We have maintainability because we're really separated by concern what does what. Plus we have our complete infrastructure as code. So we can put it into Git and always go back. What was my architecture 2 weeks ago? Check it out. And the most important point, which I'd like to convey to you, is the flexibility. Because the architecture you saw was my architecture. I tried some stuff worked, some stuff didn't work. It doesn't mean that it has to work for you. There's some components where you say, I don't need that. Or other components where you say, but how does he do it? He definitely need that. And the nice thing is Docker, and especially Docker Compose, is plug and play. You can configure it like you would like to. So if you say, well, but I need an in-memory broker, plug in Redis service. I need a graph database. You can go with Neo4j. If you're more into the web development, you can add an nginx, combine it with all the endpoints, If you have to take care of all that stuff, you might want to add a Prometheus service or a full text search with Solr. It's completely up to your needs. This might be how you feel right now. So there was a lot of information, quite short amount of time. I always showed you some fragments. And what I hoped is, or what I didn't hope is that you go back home, you try this out, nothing works, and you blame me again. So that's why I created Cookie Cutter. Just very briefly, Cookie Cutter is some sort of bootstrapping engine written in Python. I won't show you the videos, but everything you do is Cookie Cutter, the link, which is also in the repository. You have to provide the name and the password, and all the stack is configured just for you. So thanks for listening. Before we end up in the Q&A section, I think we don't have too much time left. Just 3 more resources. So first, a talk from the SciPy 2016 about data science as software. Very interesting if you like to have a bit more ideas about reproducibility. On the right-hand side, Docker for Data Science, really interesting book that also brings you up from the bottom, how to use Docker for data science tasks. And sorry for doing so, but small advertisement at the end. Over the past half year, I actually created a MOOC on Udemy exactly for this topic. It's currently under review. And if you'd like to pre-register, you only have to go to beyond-jupyter.io. And you can, as I mentioned, pre-register and being notified when the course officially launched. So I got the red card, meaning we have 5 more minutes for questions. Thanks for listening, especially after the lunch. And I'm happy to take the questions. Yes.
Thank you for your talk. I want to know where version control fits in all this. How do I do it? Does Git go here somewhere?
Sure. What you can do, I mean, if you use the Cookie Cutter, what you'll see, or basically, you will come up with an architecture that looks exactly like this. So it's basically just a Docker Compose file with some other supplemental files, which helps you to keep track. And it's actually Git source version control. So you can simply, I mean, it's Docker Compose is just a file. This is your whole infrastructure. You can create a new repository, have it there, check it out, check it in, create feature branch, merge, hotfix, whatever you like. Welcome. Other questions? Or fed up by the food and the mental food? Okay. Oh, sorry. Yeah.
So you mentioned reproducibility in the beginning.
Yes.
I think, and you said so you're saving the data with the timestamps, so you know
the models. Yeah.
Results,
Yeah.
Yes. But do you also save the code that produces these model results?
Exactly. So I just repeat the question. So the question was about, okay, or the model, or in general, the reproducibility. So you do store the models with timestamps, but do you also save the code which produced it? And that's actually a good point, because if you take a look at this talk I mentioned in the beginning about I don't like notebooks, it's really hilarious. They have, they actually have one slide with what's the name of Al Bundy's wife? Peggy. So they have one picture and say Jupyter makes you make bad habits. And you see Peggy with like a bunch of cigarettes, because that's actually what Jupyter does. So Jupyter doesn't help you with this. If you have Jupyter, you just run your model code, you can't really track it. But if you do it with this architecture, you're forced to outsource the code that retrains the models. You're forced to extract the code that produces the model, put it into an own file, because if you'd like to use one of the other components, like the scheduler needs to have the code. It can't directly access the stuff which is on the Jupyter container. It really has to have the code. So if you're going this way, you're forced to go into a really modular mode, which you can then track by normal source version control. If this answers your question.
I guess you could also deposit the code together with the produced model results in your database.
As you like, of course. Okay, cool. So thanks for your attention. I hope you're thrilled and also producing your first Docker images, and enjoy the rest of the PyCon. Thank you.